Good evening, students. Good evening, Charan Sai. Sorry for the trouble. Okay. Okay. In this class, we are going to discuss in detail about the Arrhenius theory of acids and bases. So, coming to the acid is a substance that ionizes in water and produces H plus ions. So, for example, let us consider the general case. So, acid is a substance that ionizes in water and produces H plus ions. So, good examples of acids include HCl, H2SO4, HNO3, perchloric acid, etc. So, in general, acid can be represented as HA. So, according to Arrhenius, what is an acid? Acid is a substance that ionizes in water. So, it produces H plus ions. Remember that acid-base reactions are reversible. So, it ionizes in water and produces H plus ions. So, for a reversible reaction, so always there exists an equilibrium. సో యాసిడ్ బేస్ రియాక్షన్స్ అనేవి రివర్సిబుల్. సో డెఫినెట్గా ఈక్విలిబ్రియం స్టేట్ అనేది అటైన్ అవుతుంది. సో ఆ ఈక్విలిబ్రియం స్టేట్కి ఈక్విలిబ్రియం కాన్స్టెంట్ క్యాలిక్యులేట్ చేయొచ్చు. ఇట్ ఈస్ కేఏ. కేఏ ఈజ్ ద డిసోసియేషన్ కాన్స్టెంట్ ఫర్ అన్ యాసిడ్. సో అకార్డింగ్ టు అర్హీనియస్, యాసిడ్ అంటే ఏంటి? దట్ అయోనైజెస్ ఇన్ వాటర్ అండ్ ప్రొడ్యూసెస్ హెచ్ ప్లస్ అయాన్స్. ఏదైతే సబ్స్టెన్స్ వాటర్లో అయోనైజ్ అయ్యి హెచ్ ప్లస్ అయాన్స్ని ప్రొడ్యూస్ చేస్తుందో అది యాసిడ్. సో లెట్ us calculate the equilibrium constant for the dissociation of an acid, and according to law of mass action it can be written as the molar concentration of products divided by the molar concentration of reactants. Okay. So similarly, how to define a base? So base is a substance that ionizes in water and produces what type of ions? Will you answer? Yes, it produces OH minus ions in water. So for an instant, let us consider good examples of very good. Tilak, Rebecca, very good. OH minus ions. Now tell me, what are the good examples of Arrhenius acid? Meanwhile, I will write the general equation of the base, that is BOH. So it ionizes in water and produces OH minus ions. Sai, I am asking good examples of bases, not acids. What are the good examples of bases? So here also we can calculate the equilibrium constant of bases Kb. So Kb is equal to molar concentration of products divided by molar concentration of the reactants. Okay, very good. Rajeshwari, Tilak, very good. Rebecca, very good. But NaOH is only base according to Arrhenius. So NaOH, KOH, lithium hydroxide, barium hydroxide, all these are acids according to Arrhenius. Next, we will discuss about the neutralization reaction. So, what is meant by a neutralization reaction according to Arrhenius? So, neutralization reaction generally involves the formation of undissociated water molecule. So, according to Arrhenius, what happens in the neutralization reaction? Very good, Swati. Sai, very good. So, H plus ions reacts with OH minus ions. So, according to Arrhenius, the neutralization reaction involves the reaction between an acid and a base in such a way H plus ions from acid react with OH minus ions from the base and results in the formation of undissociated water molecule. So, according to Arrhenius, the neutralization reaction involves the formation of undissociated water molecule. So, he also explained the strength of acids and bases. So, coming to the strength of acids and bases, strong acid means it is a substance which produces more number of H plus ions. Strong acids produce more number of H plus ions. Coming to the examples, it includes perchloric acid, HCl, H2SO4, HNO3, etc. Very good, Swati. So, strong bases means they produces more number of OH minus ions. Will you give good examples for strong bases? Yes, very good. NaOH, KOH, etc. So, moving to the weak acids. Weak acids means, can anyone answer? Yes, they produces less number of H plus ions. So, weak acids produce less number of H plus ions. What are the good examples of weak acids? Weak acids are very important. Acetic acid, boric acid, phosphoric acid, etc. Even carbonic acid. So, these are good examples of weak acids. Coming to the weak bases, they produce less number of OH minus ions. And what are the good examples? Yes, they include ammonium hydroxide, lead hydroxide, aluminium hydroxide, etc. These are very good, Rebecca, Rajeshwari. Yes, weak bases produce less number of OH minus ions and generally they include ammonium hydroxide, lead hydroxide, aluminium hydroxide. Next, we will discuss about the degree of dissociation. What is that? Degree of dissociation. And Arrhenius explained the strength of acids based upon degree of dissociation and it can be represented with the letter alpha and it is the ratio between number of molecules dissociated into ions divided by total number of molecules taken. So degree of dissociation alpha is the ratio between number of molecules dissociated into ions to total number of molecules taken. So especially for strong acids, the value of degree of dissociation is nearly equal to 1, and for weak acids it is always very less than 1. Clear? Since, for example, when you consider strong acids, they dissociate completely and gives the corresponding H plus ions. In the similar way, when you consider weak acids, they dissociate to a little extent. So, strong acids అనేవి కంప్లీట్గా డిసోసియేట్ అవుతాయి. ఇఫ్ యూ టేక్ 100 molecules, 99 molecules undergoes dissociation. బట్ వీక్ యాసిడ్స్కి వస్తే మీరు 100 molecules తీసుకుంటే ఓన్లీ 2 molecules డిసోసియేట్ అవుతాయి. సో ఆల్ఫా వాల్యూ ఏమవుతుంది? ఇట్ ఈస్ వెరీ లెస్ దాన్ 1. ఓకే, అప్రాక్సిమేట్లీ ద డిసోసియేషన్ విల్ బి అరౌండ్ 2% ఫర్ వీక్ acids or bases. Clear? And remember that this theory is applicable to aqueous solutions only. So that is the first limitation. So this theory is applicable to aqueous solutions only. సో ఎప్పుడైతే మనము సబ్స్టెన్సెస్ని వాటర్లో డిజాల్వ్ చేస్తామో అప్పుడు మాత్రమే ఎసిడిక్ ఆర్ బేసిక్ నేచర్ అనేది ఎక్స్ప్లెయిన్ చేయగలుగుతున్నాము. సో దిస్ థియరీ ఈజ్ నాట్ అప్లికబుల్ టు నాన్ యాక్వియస్ సొల్యూషన్స్. దిస్ థియరీ ఫెయిల్స్ టు ఎక్స్ప్లెయిన్ ద ఎసిడిక్ నేచర్ ఆఫ్ substances like CO2, SO2, etc. So this theory fails to explain the acidic nature of CO2, SO2, etc. Similarly, it fails to explain the basic nature of NH3, Na2CO3, CaO, etc. సో అర్హీనియస్ థియరీ అనేది నాన్ యాక్వియస్ సొల్యూషన్స్కి అప్లికబుల్ కాదు. CO2, SO2 లాంటి సబ్స్టెన్సెస్ యొక్క ఎసిడిక్ నేచర్ ఎక్స్ప్లెయిన్ చేయలేదు. అమ్మోనియా, సోడియం కార్బోనేట్, కాల్షియం ఆక్సైడ్ లాంటి సబ్స్టెన్సెస్ యొక్క బేసిక్ నేచర్ని ఎక్స్ప్లెయిన్ చేయట్లేదు. అలాగే ఇట్ ఫెయిల్స్ టు ఎక్స్ప్లెయిన్ ద న్యూట్రలైజేషన్ రియాక్షన్స్ which do not involve the formation of undissociated water molecule. సో ఏ రియాక్షన్స్లో అయితే అన్డిసోసియేటెడ్ వాటర్ మాలిక్యూల్ ఫామ్ అవ్వలేదో అలాంటి న్యూట్రలైజేషన్ రియాక్షన్స్ని ఎక్స్ప్లెయిన్ చేయట్లేదు. బెస్ట్ ఎగ్జాంపుల్ ఈజ్ ఫార్మేషన్ ఆఫ్ కాల్షియం కార్బోనేట్. సో దిస్ రియాక్షన్ ఈజ్ అన్ యాసిడ్ బేస్ రియాక్షన్, బట్ it is not applicable in terms of Arrhenius theory. Why? It do not involve the formation of undissociated water molecule. At the same time, this theory fails to explain the formation of hydronium ion. So according to Arrhenius, when H plus ions are present in water, they associate with water and results in the formation of H3O plus ion, and they are called as hydronium ions. సో అర్హీనియస్ థియరీ ప్రకారం H ప్లస్ అయాన్స్ కనుక వాటర్లో ఉంటే అవి వాటర్తో అసోసియేట్ అయ్యి H3O ప్లస్ అయాన్స్ని ఫామ్ చేస్తాయి. సో ఎందువల్ల అలా ఫామ్ చేస్తాయి అనేది ఎక్స్ప్లెనేషన్ ఇవ్వలేకపోయారు. ఓకే, లేటర్ హీ మోడిఫైడ్ his theory by introducing two important aspects that, according to modified Arrhenius theory, acid is a substance that increases the concentration of H3O plus ions. So modified Arrhenius theory ప్రకారం యాసిడ్ అనేది మనకి వాటర్లో H3O ప్లస్ అయాన్స్ యొక్క కాన్సన్ట్రేషన్ని ఇంక్రీజ్ చేస్తాయి. సో లెట్ us ఎగ్జామిన్ HCl plus H2O. So it gives rise to H3O plus Cl minus. Clear? So according to modified Arrhenius theory, acid is a substance that increases the concentration of H3O plus ions in water. So it is the general case. Let us apply to CO2. So then it becomes H3O plus HCO3 minus. So modified Arrhenius theory explains the acidic nature of substances like CO2 and SO2. Similarly, base is a substance that increases the concentration of OH minus ions in water. So modified Arrhenius theory ప్రకారం బేస్ అంటే ఏంటి? ఏ సబ్స్టెన్స్ అయితే మనకి వాటర్లో OH మైనస్ అయాన్స్ యొక్క కాన్సన్ట్రేషన్ ఇంక్రీజ్ చేస్తాయో వాటిని మనం బేస్ అనొచ్చు. క్లియర్? సో కమింగ్ టు ద గుడ్ ఎగ్జాంపుల్, let us consider ammonia. So when ammonia is present in water, then what happens? It increases the concentration of OH minus ions by producing NH4 plus ions. So in that context, ammonia is a base according to modified Arrhenius theory. This is all about the Arrhenius theory. Now it's the time to discuss about the multiple choice questions based upon the Arrhenius theory. So coming to the multiple choice questions based on Arrhenius theory, the first question is the strongest acid among the following: HClO4, option B HClO3, option C HClO2, option D HClO. Try to answer. త్వరగా ఆన్సర్ చేయండి. ఎస్, వెరీ గుడ్. మహేంద్ర, రిబ్బకా, రాజేశ్వరి, అభిలాష్, వెరీ గుడ్. సో perchloric acid is the strongest acid. Since here the oxidation number of chlorine is +7, +5, +3, and for option D it is +1. So here chlorine is having highest oxidation number, with the result H plus ion can be produced more readily. That's why perchloric acid is the strongest acid. Clear? Coming to the second question, which of the following represents the formation of hydronium ion? సో కింద ఇచ్చిన ఏ ఈక్వేషన్ ప్రకారం మనకి హైడ్రోనియం అయాన్ ఫామ్ అవుతుంది? వెరీ గుడ్ బాను, సాయి, వంశీ, వెరీ గుడ్. So according to Arrhenius theory, whenever H plus ions are present in water, it results in the formation of hydronium ion. Very good. Moving to the third question, the relative strength of hydrohalic acids. A acids hydrohalic acids are in the order? Will you guess? Within few seconds, you are supposed to guess right answer for the third question. Next, I will explain which one is the correct order and why. No, it is not option B. Now listen to me. You are not familiar. Option D. Who said? Abhilash. Very good. Option D is the right answer, and I will give you the explanation. So here, when you consider hydrohalic acid, as the anion size increases, it is very easy to remove hydrogen as the proton, because a sigma bond is formed between hydrogen and the halogen, isn't it? Hydrogen is having 1s orbital, but coming to the anion, as the size increases, then what happens? The bond between the hydrogen and halogen becomes weak. So the anion with large size is more stronger than the other acids, and hence the correct order is HI is stronger acid than HBr than HCl. Clear? We will move to the next question, that is, here also you are supposed to guess the increasing order of acid strength of phosphoric acid, carbonic acid, HCl and HI. I think you are familiar with the strength of HCl and HI. Which one is more acidic? Will you guess the right option? No, it is not B. Listen to me carefully. Carbonic acid is the weakest acid. So option C is the right answer. Carbonic acid is the weakest acid. Okay. Phosphoric acid readily gives H plus ions. So when you compare carbonic acid with phosphoric acid is more stronger than carbonic acid. So that's why option C is the right answer. Moving to the fifth question. Arrhenius neutralization reaction involves the formation of. Now you can answer. It is very easy question. Very good, Charan Sai. So it involves the formation of undissociated water molecule. So option D is the right answer. Very good. Anand, Rebecca, Sahiti. Very good. Everyone is giving the right answer. Now it's the time to discuss about the sixth question, that is dissociation of weak acid is. So weak acid యొక్క dissociation ఎలా ఉంటుంది? Option A 90%, B 70%, C greater than 3%, D less than 3%. Very good. You are trying to answer, but tell me the right option. S, Banu, Mahendra, Abhilash, Sai, Rebecca. Very good. Option D is the right answer. Always the dissociation constant, degree of dissociation is very, very less. That means the dissociation is less than 3%. Option D is the right answer. Coming to the seventh question. Arrhenius theory is not applicable to. Arrhenius theory దేనికి applicable కాదు? చూడండి. Charan Sai, very good. Bhavani, Bhanu. Very good. You are too good. It is not applicable to non-aqueous solutions. So nice. Next we will discuss about the 8th question. Arrhenius theory is not applicable to. Remember, it is only Arrhenius theory, not the modified Arrhenius theory. Yes, Charansai, Vamsi, Abhilash, Bhanu, Rajeshwari, Rebecca, Tilak. Very good. So it is not applicable to CO2 and SO2 like substances. Few more questions to go. Which of the following is not a base according to Arrhenius? 9th question answer cheppandamma. Very good. Bhanu, very nice. Vamsi, Charansai, Abhilash, Sai Charan, Sujit, Rajeshwari, very good. Option D. Option B is the right answer. Coming to the last question. Which of the following statement is true according to Arrhenius theory? Be careful. Option A. Acid increases OH minus ions concentration in water. B. Base increases H3O plus ions concentration in water. C. Acid increases H3O plus ions concentration in water. D. Base decreases OH minus ion concentration in water. Very good. Charan Sai, Tilak, Vamsi, Sai Charan, Bhanu, Sujit, Rajeshwari, Abhilash, Swati. Yes, you are correct. So option C, acid increases the concentration of H3O plus ions in water. I think that is enough for today. Have a nice day. Good night.